Continuing with June 2012, remember that your negative exponent causes you to take the reciprocal. 2 to the negative 1, we would take the reciprocal to the positive. So any of your negatives, you're going to flip to the opposite side. Keep your y to the 4th on top, move your x to the 1 on the bottom. You have a 3, put your x to the 5th on top, and put your y to the 1 on top. Now combine your like terms. This is the 5th, y to the 5th over 3x, and then reduce this one. 1 will come out of here, and you will get x to the 4th, y to the 5th, over 3, which is your first choice. Okay, and number 11, we're looking at the log equation. Remember, your log is the inverse of your exponential. Your exponential goes like this. Your log goes like this. It passes through a common point of 1, 0. Because that's a y equal, you can put it right into your y equals. If you use your change of base, it will allow you to change this to a 2 and an x. If not, use your change of base formula. Go like this and put the log x on top over the log 2. And you will get your log equation to come out in your graph of 1. Number 12, draw a picture whenever possible. You're looking at a pizza with a 12-inch diameter. So therefore the radius is half of that, 6. It's cut into 8 congruent pieces. So here's your pizza in 8 parts. Each of these angles is the same. So 360 divided by 8, there's my 45. 2 pi.
Mr. Desiderio, please report to Ms. Siegel's office. Mr. Desiderio, please report to Ms. Siegel's office.
There's my pi over 4. So each one of your angles is 45 degrees. You want to know how long the length of one of those edges of your piece of pizza. So we have a nice little formula called SOAR. S, which is the arc, which is this, is equal to the angle times the radius. A nice way to remember this is radius. Your angle is radians. So to find that arc, we're going to take your angle, pi over 4, and we're going to multiply it by your radius. And all they did was reduce this. If you multiplied in degrees by accident, and you got 45 times 6, that's a heck of a pizza crust. You would be 270 of whatever's. So that's way, way, way too big for your pizza crust. So make sure you put your angle in radians. Number 13, this gives us a radical, which we've seen in other regions as well. Remember to isolate your radical. This is key. And in this case, it is isolated. It's all by itself. And to undo your radical, you're going to square both sides. Radical pops out. And this, don't forget to multiply this out. There's no shortcut to this. So this is x squared plus 6x plus 9. So you can see from this that you have a quadratic. So get everything to one side. Subtract 5x, subtract 29. And then you can factor this. thing is, with absolute value, with radicals, you need to go back and check. So you can go back and check, and we can see that we're going to have to eliminate this one, we reject this one, and we have one solution. Another nice way to do this, besides plugging them all in, is putting this in your y1, putting this in your y2, graphing, and look where they intersect. They will intersect when x is 4. That's an easy way to do this if you don't want to work the whole thing out. Here we have it factored completely, which we see every regent as well. Since we have 4 terms and not everything contains an x or a number that we can factor out, we're going to group. So out of the first grouping, we're going to take out an x squared and be left with an x plus 3. Out of this grouping, we want to be left with an x plus 3. Notice you're going to take out a negative. A negative 4 gives you the x plus 3 left over. Here's your common factor, and you're left with x squared minus 4. Now, notice that is here, but they said factor completely. So factor this into your perfect squares. Which will give you this choice. In number 15, here's your binomial expansion. Whenever you see a binomial expansion, do a small one. X plus 2, x plus y squared. Notice you get one extra term. Your first term has the decreasing exponent. Your second term has an increasing exponent. So if my exponent is 6, I have 7 terms. Halfway through is right here. This is my halfway. This is my 4th term, halfway through. Put your C's out. This is 6, 0, 6, 1, 6, 2, 6, 3. This is the guy I want. Now, your first term in this is x over 2. Notice your first term over here has a descending variable. So this would be your 6 here, your 5, your 4, your 3. My second term, and include your negative, is 6 minus 3, which is also 3. From here, you can work this out. You can put this part in your calculator, 6, 3, 6, C3. Put that in your calculator first. And then cube the rest. So this you would get 20. You would get x cubed over 8. And this would give you negative 8y cubed. The 8's are going to come out. You still have a negative here. So you're going to end up with a negative 20 x cubed y cubed. And that's going to be choice 3. Okay, number 16. We're looking at a composition of functions. Remember, in your composition, you start at the right and you roll it into the left. So we're going to start with p of x, which is x squared, and we're going to put it into m of x, which is the sine of x. You take p of x and you plug it into this x. So you're going to end up with the sine of x squared. Now, we're going to take that and roll that into n of x. You take this entire thing and you plug it in for this x. And there's your answer for your composition. This one is nice, but you have to be careful here. You've got a cosecant, which is the reciprocal of your sine. So you're going to make sure your calculator is in degrees, since we're working with your degrees in minutes. and you're going to do 1 over the sine of 138 degrees, 23 minutes. You're going to find this in second apse, where it says angle. The first one is a degree sign. So you're going to put your 138 degree sign, 23, drop down, there's a minute sign. And to the 4 places, you should come out with this one. Number 18 asks you a one-to-one. To become a function, you need to pass a vertical line test. To become a one-to-one, you need to pass a vertical line test, and you need to also pass a horizontal line test. So you can graph those because they're all y equals, and you can see which one passes both. Now, when you look at them, here's your absolute value. Here is your cubing function, just a little translated up. And here's your parabola translated up. These two will not pass a horizontal line test. And this one also, x to the 4th, comes up like that. That will not pass a horizontal line test. So number 2 passes both. Conjugates, now remember the deal with the conjugates. Conjugates are your perfect squares. So the only thing that should be different is the sign in the middle. So keep the same terms, different sign in the middle. Those are your conjugates. Such as these are your perfect squares. These all stay the same. The one that changes is the one in the middle. So your conjugate, therefore, would be this one. That was a nice little question. Okay, number 20, what is the positive value of the tangent of 1/2 x? Make sure you keep your formula sheet handy because this is on your formula sheet. So you're going to pull up this formula and you're going to plug this in. Tangent of 1/2 x is equal to the positive and negative of 1 minus the sine of x over 1 plus the sine of x. You only want the positive, so we don't have to worry about it. And they did give you the sign. So just plug it in. 1 minus 0.8 over 1 plus, sorry. Oh, we need the cosine. My mistake. We need your cosine. Okay, so to get our cosine, let's pull out our cosine first. We have a little identity that you have to remember. This is the only one you have to remember. So write this down so that you remember this one. So we've got 0.8. Put it in the sign. We don't know what our cosine is. 0.8 squared equals 1. And solve for this. Take the square root, and the cosine is 0.6. That's what you're going to put into here. So we're going to put in your 0.6, and we're going to put in your 0.6 down here. Now the rest of this you can actually do on your calculator. Just be careful of your fraction. Make sure if you're using it without the fraction bar, you put it like this. This will become 0.4 over 1.6, which becomes 0.5. Number 21 is asking you to find the value of k. And it tells you that the average of this is 2. two ways to do this. L1, L2, and substitute each one of these in for here until you find the mean of 2. That's the easiest way. The correct way is to use your rule. Because this is a frequency, you're going to have to multiply these guys. And then you're going to add them all up and divide by how many there are. So technically, you have to say 0 times 4 plus 1 times 6 plus 2 times 10 plus 3 times 0 plus 4 times k. There's your variable. Plus 5 times 2 over, and you got to add all these up. 4 plus 6 plus 10 plus 0 plus k plus 2. Collect your like terms. You know this is going to be 2. There's your average. Collect your like terms. You need to solve for k. And cross multiply, and you'll come up with k. I think it's easier to do the L1, L2, and plug each one in and do a one-var stat. And make sure you do L1, L2. When your mean says 2, you got the answer. How many negative solutions to this equation? Since it's a y-equal equation, graph this. When you graph this, you're going to see some kind of a cubing function, and you're going to notice that there are no negative solutions to this. Okay. Number 23 gives us a probability problem. You'll notice that it says the probability is 80%. And notice they use all fractions. Just take 80% and convert this to a fraction. Put an 80 over 100 and have your calculator reduce it to your fraction. So the probability that a student texts while doing homework is 4 over 5. The probability that they text is 4 over 5. The probability that they do not text is 1 minus this. 1 over 5. You've got the probability of success and the probability of failure. This is your binomial. So which expression would be part of the process used to determine at most 7 out of the 10? We're going to do this 10 times, and we want at most 7. At most is like money in your pocket. If you have at most $7, you have 7 or less. So you have 7, 6, 5, 4, 3, 2, and 1. Each one of these keeps your 10, 7, your 10, 6, and all the way down. Notice we don't use a 10, 9 or a 10, 8. So it's going to be one of these. So you can tell right here, this 7 should be right up here. So it's not this one. So here is your rule for your 6. Probability of being successful, measure your successes first, and then your failures. We want 6 of these, so therefore 10 minus 6, 4 of those. We could almost do that one with the process of elimination. Also, these values cannot add up to more than 10. So this one did add it up more than 10, and so did that one. So that's a good thing to look at when you're looking at your probabilities. Okay, number 24. In which interval of f of x equals cosine of x is the inverse a function? The inverse is only a function when it passes both a vertical line test and a horizontal line test. It has to be a one-to-one. So if you remember, we restricted your cosine to where it turns. We cut it off here, and it turned, we cut it off here. So from 0 to 180 degrees. So from 0 to pi is your restricted domain for your cosine. In number 25, they're again looking for your linear correlation coefficient. This is the R when you do a linear regression. So we're going to put this in L1. We're going to put this in L2. We're going to do your linear regression, L1, L2, and we're going to look for your R, your correlation coefficient. Now, if you do not see an R, and you should, you're going to make sure that you go and say second catalog and come all the way down to diagnostics on. Hit enter and hit enter until it says done. And then retry this and you should see your R. And that's what your R came out to be. Okay. They're just looking for your correlation coefficient. How true to a line of best fit? The closer to -1 or +1, the truer the line of best fit. In number 26, we're looking at two distinct triangles. This is your ambiguous case of sine. Sine is the only one that has an ambiguous case. Now, there's two ways to look at this. If I want to draw my triangle, and here is angle M, and here's my side M over here. Here's my N. I want to know how high my altitude is. Remember, this side has to swing. If it falls like this, then I could make 2, depending on what my altitude is. So I'm going to take a look at my first angle, angle 35, if I put 35 in here. And I'm going to find out the height of this. This is a sine function. And I can find this out to be 5.7. If I notice this is 5.7, I notice 6 is larger than 5.7. So it's going to swing and make me 2 triangles. If I try the 45, it's going to be 6.4. It's longer than 6, so it's only going to swing me to one side. That's one way to do it, to determine that the answer is 35. Another way to do it is your law of sines. 6 over 35, the sine of 35, and 10 over the sine of n. Remember, sine is positive in quadrants 1 and 2. That's what makes your ambiguous case. When you find this, you're going to find you can have 2 possible angles, a 73 degrees or a 107 degrees, because sine is positive in both of those quadrants. If we perform cross multiply and find the sine of n, it's equal to this. Sine is positive in 1 and 2. So in quadrant 1, if you did second sine and found this, you would find your 73. If you put this reference angle in quadrant 2 and do 180 minus 73, you find your other one. If they both exist, then yes, you have the ambiguous case. You have 2 triangles, 2 distinct triangles. In number 27, you're looking at order does not matter. If order does not matter, as in committees, you're looking at combinations. So the best way to do this is just set them both up. But be careful. 5 out of 15 sets up 15C5. Just put it in your calculator. 5 out of 25, 25C5. 20 out of 25, 25C20. These will be the same. And 25C15. So these are basically the same. So it's not going to be one of those. Whenever these external ones, these outside ones add up to the same thing, to the same one that our n is, then they end up with the same combination. So it's not going to be one of those. So put these in your calculator and you're going to determine that that yields you more. 3,268,760 different committees.